Welcome to Brain Vision.
So you're looking at this sample here that has 215 torr of N2, 102 torr of O2, and 117 torr of HE. So the total pressure of the mixture is just equal to the sum of the partial pressures, right? So this equals 215 plus 102 plus 117. 434 torr. Okay, and so to find the mass of each gas present, we are looking at a 1.3 liter sample, or 1.35 liter sample at 25 degrees Celsius. So we can just use the ideal gas law to find the number of total moles of gas first, right? So we know the total pressure is 434 torr. There's 1.35 liters. There's n moles. And the ideal gas constant we want to use since we're given it in torrs, we would want to use 62.36. Okay, and this is in liter torrs per Kelvin per mole. And then the temperature is going to be 298.2 Kelvin. So the total number of moles of this gas is going to be 62.36 times 298.2, and then take 434 divided by that. Okay. And so in total, you have 0.0315 moles of gas. And so now you just multiply by the mole fraction of each times 215 over 434 is 0.0156 moles of N2, which corresponds to roughly 0.437 grams of N2. You can do the same thing for oxygen. The total gas mixture consists of 0.0315 moles. Each gas molecule, because we're assuming they're ideal here, contributes the same amount to that pressure. So this is 0.0074 moles of O2, which corresponds to roughly 0.237 grams of O2. Finally, you got helium. This is 0.0085 moles of helium. Helium's got a molar mass of 4. This corresponds to roughly 0.0340 grams of helium. So to recap, to find the total pressure, you just add all the partial pressures together. Okay. And then to find the mass of each individual gas, you find the moles of each individual gas, which is proportional to the mole fraction, which is proportional to their partial pressure over the total pressure. Okay. And you can find the total number of moles just from the ideal gas. We also equivalently could have done this individually. Okay, we could have taken the individual partial pressure of each gas and plugged it into the ideal gas equation. That would also be a valid way you would get the same solution. This is also a valid way. Both of them give you the right answer.